This is the video for lesson 5.3a, which is about some bisectors in a triangle. The 5.3a lesson is about a special one called a circumcenter. So you'll be able to identify properties of perpendicular bisectors and angle bisectors, which is a lot like one of the learning targets we've had earlier this chapter. Real quickly, just to show you what we're talking about today, in this triangle, if you draw all of the perpendicular bisectors, they run into each other. All right, and that's part of what we're going to talk about today. So if I click on Show Perpendicular Bisectors, what happens is all of these green lines are going through the segment at 90 degrees and cutting the segments in half. All right, so that's just a fast way of popping up the answer for you. All right, I can click on Show Circumcenter. That circumcenter is that green, I know probably hard to see, dot right in the middle right here where they run into each other. All right, and what happens if I look at moving around this circumcenter in certain for certain types of triangles, the circumcenter might be right on the edge of a triangle. It could be one of the sides for a special type of triangle. For another type of triangle, the circumcenter might be outside, and then we might have circumcenter inside as well. So we'll talk about what it is and why it's important here right now. So before we do that, we have to talk about concurrent lines. Concurrent lines are three or more lines that intersect all in one point. The point of concurrency is where the three lines would be running into each other, the point where they are intersecting. Perpendicular bisector is a line, a segment, or array that is perpendicular to the segment at its midpoint. So right at the midpoint is where you have the perpendicular line going through. All right, so what happens in this theorem is saying that a circumcenter always exists. It says the perpendicular bisectors are concurrent at a point, and here's going to be the important part of what we're looking at today, that is equidistant from the vertices. So what that means, here's my circumcenter. It's made by these red lines that are perpendicular bisectors. What ends up being true is the distance from P to C is the same as the distance from P to A, which is the same as the distance from P to B. So what happens, excuse my bad art, but what happens is you can draw a circle that goes perfectly through each of the 3 points around the triangle. Okay, so the fact that they're equidistant from the vertices means you can pop that circle up that goes through all 3 points. Okay, the point of concurrency is called the circumcenter, like I called it before. The circumcenter of the triangle is the spot where the perpendicular bisectors meet. So it's where the perpendicular bisectors run into each other. Since the circumcenter is equidistant from the vertices, you can use the circumcenter as the center of the circle that contains each vertex. You would say that the circle could be circumscribed about the triangle. So what that means is, in this picture here, what I have is a situation where if these are all perpendicular, or I'm sorry, if this is the circumcenter right here, I'm definitely the same distance away from A, C, and B, which means each of these could act like a radius of the circle with the center as the circumcenter. Okay? So that's just what the vocab means. The circumcenter is a point where you can circumscribe the triangle. Okay? And like we talked about, the circumcenter of a triangle can be inside, outside, or on. So for any acute triangles, your circumcenter will be inside. For any right triangles, your circumcenter will be on the triangle. For any obtuse triangles, your circumcenter will be outside the triangle. And that's always going to be true. Okay? We'll do a couple examples with it of just trying to find it. So what we would need to do is talk about how do you find it on a graph? How do you find that circumcenter on the graph? So with this situation over here, if you remember, back to chapter 3, we talked about vertical lines and horizontal lines. So on this left-hand triangle, I have a vertical line running into a horizontal line right here, which means I know that this is a right triangle, which means I expect my circumcenter point to be on the triangle itself, okay, on one of the sides. It usually ends up being the hypotenuse, or it always does. So what I need to do to find the circumcenter of the triangle is I need to draw the perpendicular bisectors and see where they meet. All right, so to draw a perpendicular bisector, let's think about this side first. What I would need to do is find what's halfway through that point, or halfway through that line. So this segment has endpoints of 1 and 6. That means that this is a distance of 5, which means I need to put a dot halfway, or 2.5 points away, 2.5 points away from one of either endpoint. That's going to be a midpoint, meaning I know that this side is congruent to this side. Since I'm talking about a horizontal line right here, I can just draw a vertical line directly through that. Okay, let's look at the vertical line. This vertical line is 2 units tall, which means halfway will be 1 unit away from either endpoint. So I know that these two will be equal either side of the blue dot. To make a line that's definitely perpendicular to that, we're going to draw a line horizontally through that vertical side of the triangle. So I should add in my right angles. So those are both perpendicular bisectors. I need to draw specifically 2 perpendicular bisectors to see where they will run into each other. Because what I have right here is the intersection of those 2 points. And it's a little bit of a decimal this time, but that's no big deal. Right there, that's my circumcenter. That's the point where I could make a circle that goes through all 3 endpoints. All right, so to find the circumcenter, or to answer the question, I'm just going to label what the point is at. Over here, we're at 3.5 over from 0, 0, and then up 2. We'll try that a couple more times, all right? This one is particularly a little bit tougher, and I'll show you why right now. All right, so this one on the right, we're looking for that circumcenter. The easiest lines to draw the perpendicular bisectors through are the horizontal lines and the vertical lines. So if I'm looking at this vertical line here, I'm looking at, or this horizontal line, I'm sorry, I'm looking at it having a length of 6, which means three dots away from either endpoint will make either side congruent. So that's the bisector part. Now, if I draw a line vertical right through that point, what I have is a perpendicular line that goes through the midpoint, or a perpendicular bisector. So that's one. I need to draw one more to see where this intersection is going to be. Okay? So what we're going to do is have to remember a little bit about perpendicular slopes. Okay? So for right now, we need to figure out the slope, let's say, of this line right here, of this segment right here. All right? This segment has a slope of up 1, 2, 3, up 3, rise over run over 1, 2, 3. So this red line has a slope of 3 over 3, or 1 over 1, up 1 over 1. Okay, we'll come back to that in a second. Here's a little trick on a graph to find the midpoint then. I can go up half as much, so instead of going up 3, I can go up 1.5. Instead of going over 3, I can go over 1.5, and I can find the midpoint that way, just doing half of the slope. So I know those two will be the same length. Now what I need to do is I need to go perpendicular to this 1 over 1. So if the slope is 1 over 1, the slope perpendicular to that will be the opposite reciprocal. So that would be flipping the fraction, which is still 1 over 1, but opposite reciprocal, making us put a negative in front. So I need to take from that red line, I need to go down 1 over 1 repeatedly. So that's what I'll do here. I'm going to go down 1 over 1 and put a dot. I'm going to go down 1 over 1 and put a dot. Maybe one more time, down 1 over 1 and put a dot, using perpendicular slopes to decide where to draw my line so that it's a right angle. And now I have a point here that I've hit twice. So this must have been another right triangle because I have an answer here for my circumcenter. The circumcenter is here because that's where my two perpendicular bisectors ran into each other. So what I know is if I drew that last perpendicular bisector in, it would go right through that point as well. So for the answer, I need to look at what the coordinates are of this. And it looks like 0, 0 is here. So I need to go down 2. 0, -2 would be the circumcenter of that problem. Okay, let's try one more so you can see it all in action one more time. The vertices this time are 0, 6. So we're going to draw our triangle in. P is at 0, 6. We have a point P here. We have a point O at 0, 0. And then we have a point S at 4, 0. So let's draw that one in. Okay. When it's a right triangle, we want to take the easiest, when we're trying to find the circumcenter, we want to try to find the easiest sides to take the perpendicular bisector of. So that would be any horizontal sides and any vertical sides. Okay, so I have to draw at least 2 of these to figure out where that bisector, that intersection of the perpendicular bisectors will be. So I would try to avoid the slanted lines when you can. So what that means for us right now is that if O and S has a length of 4, I can put a dot 2 away from either endpoint and make the midpoint. The line that is perpendicular to that horizontal line OS will be a vertical line going through. This green segment, PO, has a length of 6, so I need to put a dot 3 away from either endpoint to make sure that I'm going through the midpoint. To go 90 degrees through the midpoint, I need to go horizontal, which means now I have an intersection which I can call the circumcenter. Okay, so we need to just answer where that is. From 0, 0 here, we're over 2 and up 3, so the circumcenter is at 2, 3. All right, so if it's a right triangle, your circumcenter will be on the triangle. If it's acute, your answer will be inside, and if it's obtuse, your answer would be outside. All right, so the only way it can get tricky on the graph is like the second one we did, where we have to think about perpendicular slopes. Perpendicular slopes are opposite and reciprocal from whatever, bad spelling, but from whatever you have for that first slope. Okay, so you're going to give a few of these a try. That's everything that we'll talk about right now for circumcenters, and we will go ahead and move on from there. 5.3b will be the next video. Good luck on the 5.3a worksheet. Thanks for watching.